Right, thanks everyone for joining us to talk about deploying Valkey in enterprise settings. So we've got myself and Ricardo here. Ricardo is one of the contributors to Valkey, doing a lot of work. You introduce yourself.
Yeah, hi. So I'm Ricardo. I'm one of the maintainers of Valkey. I worked mostly always in distributed databases, so that's my.
Yeah. And so I'm Martin Visser. I'm the Valkey tech lead. We both work for Percona, by the way. Percona being a big open source database company, big as in big in open source. And so that's us. And we're going to talk about LDAP and auditing today. So. Okay, so when you start deploying Valkey in an enterprise, right, people want certain things like availability, and they have their own monitoring systems usually. They want to have some easy management, right? It's those of us who are very familiar with Valkey, we all use all the commands and stuff. But people that are new to Valkey, or any technology, they like to have some management tools and things like that. And then the third one's usually around security, right? Okay, so where's my because it's a database after all. So where's my data? How is it secured? And all that kind of stuff. And how do we make sure that we integrate with our own authentication systems, our auditing systems? So those are the usual kind of requirements that we get. So just for context, right? Percona is an open source company. Our customers typically deploy databases that they have on-premise, so we're not a cloud provider as such. They will run Postgres, Mongo, Valkey on-premise. Okay, so if we look at the security part, right, we want to make sure that our data is, we care about data integrity. We care about that nobody else can access it, that doesn't have the appropriate access, right, things like that. So access is one of the things around this, and then usually these kind of organizations have either internal or external policies of what they need to comply to, right? So that's where, these kind of requirements come from, and then they typically use centralized authentication, they use centralized auditing, all these kind of things. So it's really about, these are the requirements that we see in the field right on-premise. So, and then we shall start with the authentication piece.
Thanks. Current Valkey capabilities for authentication are quite simple. We are able to have a set of user accounts registered in Valkey with where we have the username and password, and we can authenticate users in Valkey using the user password scheme. There's a special command for authenticating a user, but this is very limiting in an enterprise setting where most systems use a centralized authentication system to manage users and to authenticate those users in the service that they want to use. Well, since Valkey Core doesn't provide this integration with centralized authentication systems, we must use Valkey modules to extend Valkey to support these integrations. Fortunately, Valkey module API it's very good, and it already allows us to easily build modules to integrate with these centralized systems, and that's what we did, and we did that for a specific system, which is called LDAP, which is it's a very old system. So it allows you to store user information in a directory. So it's a tree of entries where you store user information and other kinds of information actually, and it's widely used, and there's a lot of it has an industry, it's an industry standard protocol, so many systems implement the LDAP protocol, like Active Directory, Microsoft Active Directory. And so it's an important protocol that allows us to integrate with many systems. So just to give a bit of context for those that don't have knowledge about how LDAP works. So LDAP stores information. It's called entries. Each user corresponds to an LDAP entry, and an LDAP entry has a unique ID, which is called, it's an attribute named at the end, which stands for distinguished name. And then it has a set of attributes, custom attributes, that, well, it tells you what kind of information it's storing. You can store all kinds of information about users, about other kinds of objects, and it's quite flexible. Okay, so there's no standard. There are a few attributes that always appear in these entries, but usually entries are full of custom attributes. So the way LDAP protocol authentication works, it's quite simple. So to authenticate against an LDAP server, or to check the credentials of a user, you basically use the pair, the distinguished name of the entry and the password. Okay, and in the LDAP protocol, you have the bind operation, which is the equivalent to the AUTH in Valkey. So you call bind with DN and password. And if it's successful, then it means that the user is valid and the password is correct. So, our valkey-ldap module, it's a Rust-based module. So it was implemented using the Rust SDK, as Dimitri presented before in the previous session. So it allows us to easily authenticate users in Valkey using the auth command. It will contact the LDAP servers to check if the user if the authentication is correct. This module is very flexible because the LDAP entry structure can also be very flexible. So we need to support that flexibility, and we also support setups where we have several LDAP servers serving the other services. We also support secure connections between our module and LDAP servers to make sure that all security compliances are respected. So this is a very simple architecture of the module. So we have the Valkey server, which is a Valkey core running, and then the module, which is a shared library. Inside has all the authentication logic, and we also manage connection pools to the several LDAP servers, and we also have take care of faulty connections. So we have a failure detector to detect when our module, when the connections between the modules and the LDAP servers are broken. We retry again. We reconnect in a transparent way. So the way the authentication works when someone runs the auth command in Valkey to authenticate. So it still does auth user and password, in this case foobar. The Valkey server will call a module API method that will be served by the valkey-ldap module. The valkey-ldap module will contact the LDAP server. In the meantime, the Valkey client gets blocked so that the Valkey server can still process other clients' requests. So we are not going to block our Valkey server while we are waiting for the LDAP response. And yeah, then the LDAP server responds to the valkey-ldap module, and the module returns to the Valkey server, telling if the authentication is successful or not. So to set up this module is quite simple. So all the users that we want to authenticate against LDAP need to be first added to the Valkey server. So we need to add the users and specify their permissions, their ACL rules. Then we configure the model by specifying the URLs for the LDAP servers. We also need to configure what kind of connections we want, if we want TLS, configure the certificates to make sure that TLS works. We need to specify the kind of authentication mode. We will see later on what the two modes that exist for authenticating against LDAP servers, and we need to configure the specific options for each mode. So, as I was saying, there are two main authentication modes for LDAP. One is called bind mode. It's the simplest one, and there's the search plus bind. So, for the bind mode, this is the most simple one because it can be used whenever the username registered in Valkey appears in the distinguished name string. Okay, so this it's very fast method because we can construct the distinguished name and just perform a single LDAP operation, the bind operation. So just one round trip to the LDAP server to authenticate a user. So as an example, imagine that we are trying to authenticate user Ben, and there's an LDAP entry there, and you see that Ben appears in the distinguished name string, so it's UID equal Ben, and the remaining. So we just, for this mode, it's very simple to configure. We just configure the prefix, so it's a template. We configure the prefix of the distinguished name and the suffix. And what valkey-ldap module do will take the prefix, concatenate to Ben, to the user passing auth, and then concatenate the suffix. And it will use this string to authenticate against the LDAP server. So, but sometimes the LDAP entries are much more, well, it doesn't follow these rules, so the username might not appear on the distinguished name, or you might want to use the email address, for instance, as the username. Okay? And in this case, we need a more flexible way to configure our module. So in this search plus bind mode, what happens is that we can tell LDAP module that he should first look for an LDAP entry that matches a certain condition based on an attribute, and then after finding that LDAP entry, it takes its distinguished name and then performs the bind. This, in the worst case, this requires 3 round trips to the LDAP server, but it allows for any kind of LDAP structure directory. So let's see an example. So in this case, the username Ben, the string Ben, doesn't appear. It doesn't appear in the distinguished name because there's a Ben Alex with capital B. What happens is that in this directory structure, there's an attribute called UID that is also unique per each user entry, and that's what we want to use. So we want the LDAP module to first search for the entry that has Ben as the UID, and then extract the distinguished name, and then use that distinguished name with the password to call bind operation. Right? So in this mode, you just need to configure 3 three configuration options. You just specify which attribute you want to use for search, which attribute contains the distinguished name. In OpenLDAP, this is usually the entry-DN attribute, and you can also pass a filter where you can basically filter LDAP entries, so you don't need to search the whole directory structure. Besides the configuration, and because we, as I said, we manage, we can connect the module to several LDAP servers, and we have a failure detector to detect if there's health issues with the connections between the module and the servers. We also provide some information in the info command. So there's a special section for the LDAP module where we show what servers are configured and their health status. So for each server that we configured, we show the host name, we show the status, so if it's healthy or not. If it's not healthy, we provide an error message so it can be easy to understand what's going on. And in case if it's healthy, we show the ping time, to show more or less if the latency between the module and the server is what is expected or not. So as I said, so this module, it has all these configuration options to support most types of LDAP deployments. Okay? So it's I'm not going through all of this, but just for you to know that it can be used in several setups. So what are the next steps for this module? So we can still improve the way we self-heal the module, because right now, if there's a network failure and all connections are broken, when the network is reestablished, we just start connecting to all LDAP servers, and well, the module can be running in a big Valkey cluster with many nodes, and so we might start a lot of connections. We can improve this. We would also like to support user groups, so because usually users belong to groups, have different permissions according to the group, and right now this is not supported. And we would like also to, in the future, try to remove this limitation that right now you need to insert in Valkey the list of users that you want to authenticate that are present in LDAP. So a sysadmin will always need to, for a new user, it needs to insert the LDAP entry and also manually insert in Valkey the user account. So we would like to just have LDAP as the source of the information, and no need to add the user in Valkey. So this is all we have. And you can get so there's the source code in GitHub. We also build RPMs for several Linux distributions. You can also get the module in the Valkey bundle container. And there's already documentation in the official Valkey website. Okay, so next audit.
Do you want to do questions first?
I guess we at the end.
Yeah, just going to do it. Yeah. Okay. Right. All right, we'll do questions at the end, and we'll combine the two. So yeah, I'm going to talk a little bit about auditing Valkey systems in terms of the data or the operations. So what do we want to do with auditing, right? It's, most systems that deal with data, and we want to prove the compliance with policies, right? It's you have a database, you have DBAs, does a DBA access, or anybody access data that they're not allowed to, those kind of things. So that's what auditing normally is used for. And it's things like user activity, right? So what data are they accessing? But it's also security events, so any logins, logouts, authentications, those kind of things, or even configuration changes, right? And typically all these audit logs are collected centrally. So let's have a look how we can do this with Valkey Core right now, right? So we have the Valkey log file, which contains errors and warnings, startup and shutdown, and replication, persistence events. And I think if you turn on debugging, it also shows you all the connections that are made. But that's kind of, what's the extent of what Valkey Core can give you in that term. There is for authentications, there is the ACL log that registers all the unauthorized attempts, but you have to go in and query that, right? It's a Valkey command. And then there's a suggested for development command, which is monitor, where you can connect a Valkey client, and it will show you everything that comes into the main Valkey server in terms of commands on that Valkey client output. So that's what Valkey Core gives you, which is not quite enough for what most people want. Okay, so we started playing around with building this as a module. You can argue that maybe it should be done in the core, but that's probably a big job, right? And also auditing is a requirement that not many people or not everybody wants. So that's why a module seems like a good place to do it. So it's a module that gives you these kind of capabilities. So it tracks user actions, it tracks connections, authentication attempts, commands, execution, etc. And unlike the LDAP module, it was written in C because I'm not a Rust person. So that's where I started with. But it's using the same Valkey module API, right? So it's the same thing you saw from Dimitri. You have those constructs like the authentication flow, the command filters, those kind of things. So what you need for an auditing system, you want to have different log formats, right? Some systems may want a CSV format, some may like JSON, all that kind of stuff. So you want some configurability there in what the output looks like. You want to obviously capture events, right, that happen on the Valkey server, but you also may want to filter these because, Valkey is known for its speed and its high throughput and all the kind of stuff. So, you may want to, let's say, exclude normal operation, right? You're interested in unusual behavior that happens on your Valkey server in terms of commands or in terms of authentications, but normal operations, your hundred thousands of gets and sets, you may want to just filter those out and not audit them because you can generate a lot of audit information very quickly. Okay, so obviously there was a concern about performance, right? Because that's what Valkey is known for, and you don't want the auditing to impact that as much as possible. You don't want to impact that. And then there's things like, if I'm authenticating, obviously as a Valkey server, the password, and if you have a set operation, what's the payload? Do I want to log that in my audit information? So you have to have some configurability there, whether to what you want to do with those payloads in terms of auditing, right? Okay, so the ValkeyAudit, we have obviously the Valkey Core, right, where all your commands happen, your connections are made to Valkey Core, your auth commands are executed there, or your authentication happens there, right? And then the module is doing the event capture, the processing and filtering for things that you don't want to audit, for example. And then you have the output part where, am I going to write to file, syslog is an option, or TCP destination. So, as I mentioned, using the standard Valkey module API, using the buffer for the command auditing. So rather than, we don't want this to be on the path of every command execution. We don't want to wait for it to write to file, right? Similar to AUTH, where we buffer stuff. We want this to happen asynchronously. And we have a separate thread for writing to destination. So in terms of the events, right, you want to classify what they are, right? Is it an authorization event? So this is all kind of, if you are familiar with these, let's say, auditing data analysis systems. They want to know what category it is, right, and who did it, and where did they do it from, which IP, and what time did it happen, all this kind of stuff, right? So those are your basic audit information. What is it? When did it happen? What type of thing did they do? So you want to track the source, right, which is obviously all available. We know which client it is and which user it is. But then, the main thing there is to, as I said, you want to potentially exclude things from auditing, that you don't audit absolutely everything. Do we want to, as I mentioned, all the gets and sets from your application, that's normal behavior. So you may want to just exclude those to not impact your performance too much. And then, as I mentioned, your payload, you want to look at, is there anything sensitive in there? So do I want to exclude it? Some people have really large keys, right? They store, just files in Valkey and all that kind of stuff. Do we really want all that data in the audit log as well? So you have some options to limit that. So for the exclusion kind of engine, we have a category filter, right? Do we only want to log things like key operations? Are we interested in config commands? Authentication, obviously, we are usually interested in, but you can turn all these things on and off to limit your audit amount of data that you audit. And as I mentioned, the main thing is really, filtering out sort of standard operations by saying this is an application user, or this is the IP address of my application server. So anything that comes from there, fine, just go straight back and don't audit any of this. Or you can specify these rules as a combination of both. Okay, so and then the output, we're buffering the output. You have the multiple formats and destinations. And then for the TCP side, there's a retry and reconnection kind of handling. There's a bit more work to do there, but so we've seen the authentication flow, right, from which Ricardo mentioned a moment ago. The authentication command is intercepted pre-execution, so the module hooks are usually pre-execution. And so in an auditing system, you want to know, okay, so someone did an authentication attempt, but you also want to know, was that successful or did it fail, right? So there was a little bit of a gap there in the module API, which Ricardo wrote a pull request for, which has been accepted and going to Valkey 9, right? So so now we can check, because the authentication from a module point of view, there's an authentication attempt, but you don't know if it's successful. You can go and query the ACL log, right? But then you got to wait until that's happened. So at the moment, it's done with a timer delay, but with the pull request, we can just do a callback and find out, was it successful, yes or no? So that's the authentication handling piece. I'm not going to go through all these configuration things, but it's using the standard module configuration part with where you have config set and get, and you have all these options available. So those are the things we can look at. Then there's the event categorization of which ones am I interested in my auditing system. Okay, so again, we can filter some of those out, include them, exclude them. And then there's the payload piece, right? So do I want to know a payload at all, or am I just interested in the key only, right? So I want to log, is it set on key A, but not the value, or I want to limit the payload and make it to, I want to log the first 10 bytes or whatever I want to do, right? That's kind of all making it a bit more flexible. So the exclusion we already talked about, again, that's configurable. So there was one kind of corner case where you may want to, let's say your application, right? Your application is expected to do key commands, but you may, your application or so let's say you excluded your application username, right? Or you excluded your IP address from your application server. But you're still interested if someone fires a config command from there, right? Because you are only expecting things like gets and sets and age sets and data operations. So there's kind of an exception overriding. What you can use is like exclude everything apart from config commands if they're coming from an application server. That's unusual behavior. So log it to the audit destination. There's some things about the TCP connection settings, obviously, and the timeouts and the reconnection type things. So there's more work to do there, but it's already having the ability to reconnect and specify how many retries and how long you wait and all that kind of stuff, right? So yeah, we'll skip that bit. So this is the thing that Dimitri mentioned as well, right? The module loading is normally the order of which you load modules is important. And so that applies to command filters, it applies to authorization. Your last loaded module, the order of that is important because let's say a customer runs both LDAP and auditing. So if the LDAP authorization handling is successful, it will never go to the audit authorization handling. So whereas so in that case you're losing the facts or your auditing capabilities of that audit event. So so you can load multiple modules into Valkey, right? So order is important there. Because if something is successful, it may not execute the next module's handling. So where are we with this in terms of performance? Right, that's obviously a concern with Valkey. Performance is of course impacted. With the exclusion, we try to limit that as much as possible. The order of this is important. There's a flag to enable it completely, disable it completely, just really for testing purposes, right? Just so you can see what impact it has. And then the more important bit is excluding users and IP addresses. And then the third part is really the events filter, where you, if you pass all those two stages, then you start looking at the events, which is the most expensive bit, obviously. So here we can see the kind of impact that you have. If you don't load the module, obviously we get 100%, right? These are just gets and sets, by the way, but if we disable it, we get pretty close, right? So the only thing is, at the start of your command filter, you say enabled yes, no. Enable yes, no, just return, so that's the impact of that. But then we can see with excluding a user, we're not getting, it's not a bad in terms of performance loss there. So if you are in a situation where you're happy with normal application operations and you want to exclude that application user and just log or audit things from non-standard application usage, then you don't pay too much of a penalty price there. And then the number 5 is really where, if you want to log everything, you're paying a pretty hefty price in terms of 20%. These are just some fairly straightforward Valkey benchmark tests, but there's some more work to be done there to try and improve that. So where are we with this? There's the info command, right, that we have in Valkey. We need to add a bunch of metrics to show how it's all running and what it's been doing, how it performs. There's more performance work to do. So the auth handling that we talked about, that's going to be added, obviously, to deal with it in the correct way. And then the more difficult one is because the command filters execute before command execution. You don't know if a command was successful or failed, so there's a bit of a dependency there to have a callback from Valkey to say this was a failed command or things like that. Possibly further event categorization and maybe exclusion inclusion based on prefixes, especially if people are using modules, right? So if you have modules, then you may want to exclude all module traffic for full text search or LDAP or whatever, right? So just make it more flexible. And we want to have a look at see how we can include this in the Valkey community. So let's do questions because we are running out of time, right? Pretty much. Yeah. Any questions? Yeah. For Ricardo as well, of course.
Hey. I would like to ask some question on the audit module. So first of all, great work. So my question is it bounded in terms of how much memory usage it can have? We don't want that could.
Yeah. Yeah, no, so that's true. So the buffer is currently a fixed length, which is something that obviously, again, that's why I didn't mention it. Should have added it to the list of changes, but yeah, it needs to be a configurable size buffer, right? Whereas at the moment it's a fixed 16K buffer. So yeah.
Just one more question.
Yeah, no problem. Yeah.
Can it be done all off the main thread so that we are never facing any kind of latency issues, which you highlighted?
Yeah, not with the module API, right? Because the command filter executes pre-command. So as far as I know, I don't think that's possible. What do you think? It doesn't. Yeah, we may need to investigate this a bit more, but to me, it doesn't seem possible. It's yeah.
Might be a good problem to solve for us.
Yeah. Cool. Yeah, we try to do as much as possible with the exclusion, right, to avoid paying that penalty. Yeah. Okay. All right. Cool. Yeah. No.
Thanks. I have a question about the LDAP module. How do you map the ACL rules for a user with the rules in the LDAP? And I mean, I understand now the sysadmin declares for a user ban the ACL rules in the files probably, but for the future that you mentioned, how you'd probably need those in the LDAP somehow, no?
Yeah. So right now, as you mentioned, like the rules are inside Valkey. So there's no way to have the rules elsewhere, and that's actually something that needs to be discussed. How we can have those rules stored elsewhere in an external system, and how do we want to manage that? Like how. This is an open question, right? There's no, we haven't discussed yet what should be the best approach, but yeah. Ideally, you would have like this set of rules stored in your external system along with the user information, and when you authenticate, you basically apply those rules. You get those rules from the external authentication system and apply them to that user session in Valkey. So, but it's still an open question on what's the best approach to achieve that.
Thanks.
All right. Thank you.